All right, so in this section, we're going to be looking at what's called the comparison test, and we're going to be looking at two in particular. One's called simply the comparison test, and one is called the limits of comparison test, and we're going to use those to help us to determine if a sequence converges or diverges. All right, so here we have this example. It says use the comparison test to determine whether the series converges. Okay, so here is our series here, summation k starting at 1 going up to infinity. All right, so we have the comparison test here. And so what the comparison test says, okay, suppose I have the summation of a sub k and then the summation of b sub k. Well, if my sequence, my series A, if it's less than B, then whatever B does, then so does A. Okay, so that means if my summation of B sub K converges, then I can say, okay, the same thing is true about the summation of A sub K. All right, and then vice versa, if my B sub K is smaller than my A of K, then that means, well, whatever my B does, my A does. So my summation of B diverges and so does my A, okay? So what we have to do is compare our sequence here to another function to decide how we can apply this comparison test, all right? So let's suppose I look at my highest exponent that I have in the bottom. So I'm gonna say that this is my A sub k, okay? So let my A sub k be this, what I have inside here. And then I'm going to let my b sub k just simply be, looking at the highest degree there, just making it 1 over k to the 4th power, okay? So then we can easily see that, all right, if I just have k to the 4 plus 5, I can definitely tell that that's going to be greater than or equal to k to the 4, right? But what happens if I do 1 over? Okay, so I can simply rewrite as 1 over. Well, if this is greater, then if I flip it and put it in the bottom, then we're going to have less than or equal. Okay, so here I have my AK being less than or equal to my BK. So now I just have to figure out then, okay, what can I say about the summation of my BK? All right, well, summation of my B sub k as k goes from 1 to infinity, okay? Well, what we're going to do here is, let me just make this look a little bit nicer. What we're going to do then is use something that's called the p-series, okay? So what does the p-series say? Well, if I have a summation of k going from 1 to infinity of 1 over k raised to the p power, then my p-series says, well, if my p is greater than 1, then my series is going to converge, okay? But then if my p, okay, whatever that exponent is, if it's less than or equal to 1, then my series diverges, okay? So here we're saying that our b sub k is 1 over k to the 4th power, okay? Well, we can see that our p-value is 4, okay? Well, 4 is indeed, right, bigger than 1, so therefore we're going to say that since our p equal 4 is greater than 1, then it looks like our b sub k converges, okay, based on that p-series, all right? Well, remember, based on the comparison test, all right, if our a sub k is less than our b sub k, then whatever our series here for the b does, then so does our a, okay? So therefore, okay, since we're saying that our b sub k converges, then we are also saying that our summation k going from 1 to infinity of our a sub k, it also converges, okay? So therefore, our series here, summation k going from 1 to infinity, 1 of the k raised to the 4 plus 5, it converges. All right, so here it says again, use the comparison test to determine whether the series converges, okay? So what we're going to do, okay, similar to the first one, we're going to take a look at our highest degree, okay? So here we have this k to the 4. So what we're going to do is we're going to take our k to the 3rd power that we have in the numerator, and we're just going to simply kind of basically compare these two. Okay, so we're going to just kind of simplify and we get k 1 over k. All right, so we're letting this be our bk. All right, so remember here this is our ak. So what is the understood exponent here? The understood exponent is just simply 1. Well, remember the p series, right? Okay, we said if our p is greater than 1, then we say it converges. But then if p is less than or equal to 1, then we say it diverges, okay? Well, here in this case, our p is equal to 1, okay? So since our p is equal to 1, then we say that the summation of our b sub k, all right, then this is going to diverge, okay? Well, since our a sub k, right, is following what our b sub k does, then we can also say that our summation of a sub k, it also diverges. All right, so here we're going to use the comparison test or the limit comparison test to determine whether the series converges, okay? So again, for this one, we're just going to look at the comparison test. So if we look at our 8 to the k here, let's see if we can compare this series a sub k to another function that looks very similar, okay? So all we're going to take here is just this piece of it here, okay? We're going to ignore the plus 8, right? So our a sub k is this 1 over 8 to the x plus k, but we're going to let our b sub k just simply be 1 over 8 to the k, okay? Well, we know for sure this is bigger than this, so therefore if we were to flip it around, okay, we have less than. All right, so we got our k being less than our a sub k being less than our b sub k. All right, so let's figure out then what can we say about our b sub k. Okay, well, we have the summation of our b sub k as k goes from 1 to infinity. All right, so same thing as summation k going from 1 to infinity of our 8 raised to the k. All right, well, here this time we have this variable, right, as our exponent, okay? So we have something that we're going to use. It's called the geometric series, all right? So last time we talked about p series, well, now we have the geometric series. So whenever we have the summation of, let's say, 1 over r is just some number raised to the k power, then if we have the absolute value of r, if that is less than 1, all right, then we're going to say that it's going to converge. All right, so here we have the absolute value of 1 over 8, right? Well, that is indeed less than 1, okay? So we're going to say that our series, based off of our geometric series here, is going to converge. So therefore, we are going to say then our summation of our b, as k goes from 1 to infinity, it converges. Okay? Well, based on the comparison test, whatever our b does, then so does our a. So therefore, our series, okay, for our a, which is the same as our 1 over 8 to the k plus 8, it also converges. And here, instead of it being 1 over r, we're going to have the absolute value of r. Okay, so geometric series summation as r goes to k. Okay, so you can see our r is 1 over 8. All right, so let's suppose we have this series, okay, summation k going from 1 to infinity of the square root of the 25k to the 6 over 9k to the 8 plus 4, okay? So again, we're going to use a comparison test. So we're going to see how can we compare our a sub k to another function b sub k, all right? So again, what we're going to do is just let our b sub k be just this first piece here, okay? So we're just kind of taking our first degrees, right? Our leading coefficients and the degrees of each of those. So let's let our b sub k be the square root of this 25k to the 6, all right? And then I'm going to do a little space here, and then we have this 9k to the 8, all right? So what we want to do then, just like we did before, we always want to see if we can find that highest degree, and we'll divide everything by that, okay? So we're going to divide this top part by k to the 8, and same thing in the bottom, divide that by k to the 8, okay? So that's how we always get our b sub k, dividing by those highest degrees. So now, in the numerator, simplifying this down, well, this is just going to become 25 over k squared, and then the bottom, that's just 9, okay? So just simply simplifying here, okay? So those go away, and then your k is just simplified to 1 over k squared. All right, well, take a look at what we have under the radical. We have a perfect square for everything. So we're going to simplify this even further. So we know the square root can go to everything since we are multiplying, okay, and dividing. So the square root of 25 is just 5. The square root of 1 is just 1. The square root of k squared with the square root and the square is going to cancel out. And then, of course, the square root of 9 is 3. So if we put this all together, we end up getting 5 over 3 times k, all right? Okay, so of course, if we need to see this step, it's 5 over k all over 3. The 3 is understood to be over 1. So you keep the top and multiply by the reciprocal of the bottom. Okay, so that's how we get our 5 over 3k. All right, so now using our p series again, right? So we can see that we have just a 3 to the k power in the bottom. So our understood p, all right, in the bottom is just 1, okay, because we have this 5 over 3 to the k, all right, and times k, not to the k, times k. And the k is understood to be to the first power, so our p here is equal to 1. Okay, so based off of the p series, then we are saying that our series there is going to diverge. All right, so that was our bk, right? So remember, we simplified our bk all the way down to equal that. Okay, so therefore the summation of our bk, it diverges. All right, and so of course our summation of AK is going to follow that same idea. Okay, of course we can see that it's going to be summation of AK, right, is less than the summation of BK, so therefore whatever B does, so does our A. Okay, so therefore our series there is going to diverge. All right, let's try the comparison test with this one, okay? This time we have a trig function in there, but that's okay. We are just simply going to take with what we have down here in the bottom, let that be our b sub k. All right, so this is our a sub k. So our b sub k, we're just going to compare it, right? Compare the a to the 1 over k to the 9. All right, well, right away, we can see we have the p series, right? Our p is equal to 9, okay? It is indeed greater than 1. So based on our p series, this is converges. Okay, this is going to converge. All right, so therefore, since our summation of our bk since it converges, then of course our a sub k is going to take on that same idea, so it converges as well. All right, well, what if we have something like this? Okay, we have 1 over 11 to the k minus 7k. All right, they are different bases, so we can't combine those two, but we're going to do what we always do. Just take that first part, let that be our bk. Okay, so the whole thing here is our a, so our b, going to just let it be 1 over 11 to the k and compare. All right, well, you can see here that here our exponent is k. All right, so it looks like our p series, right? So our p in this case is equal to k. Well, k is just some constant, right? How do we know if it's less than or greater than 1? Well, if we simply look at our summation here, k goes from 1 up to infinity. So therefore our k is indeed bigger than 1. Okay, so based off the p series, our b sub k converges. Okay, so therefore summation of our bk's, k goes from 1 to infinity, it converges. And so we can say that based on that comparison test, then so does our series for our a sub k.